In this video, I'm going to do these two examples where I complete the square. By completing the square, we take a quadratic equation like this with three terms, and we turn it into this format, which is called the vertex form. So I'm transferring the quadratic from standard form, which is the ax squared plus bx plus c format, into ax minus h squared plus k. Now, you might wonder why that's a good idea. It's because if we have a quadratic in vertex form, we could see the vertex, which is the point right over here. If the graph opens up, this point will be called the minimum value. And if it opens down, then that point will now be called the maximum value of the function. So let's take a look and try these. When we say f of x, it just means y. So y equals. So anytime there's a question like this, we can just say it's y equal to. Here's what I do. I look at the value that's attached to x squared. I don't see a number, so I'm going to pretend that it's a 1. I'm going to factor the 1 from these two terms. So it's always good to underline these so you know that you're only factoring from those two terms. So I take out the 1. Let's put the 1 here. And in the brackets, I have to think about what's left over. So like what times 1 gives me 1x squared? And that would be x squared. Then what times 1 gives me 12x? And that would be a 12x. Okay, that's the first thing I do. Next, I'm going to bring in an imaginary number. I'm going to add and subtract a value in this bracket. This value that I add and subtract has to do with the 12 here. So I take that 12, I divide it by 2, so it's a positive 12. I divide it by 2 and I square it. We always divide by 2 and square. This value is going to be 6 squared, which is 36. So I'm going to go into the bracket and add and subtract 36, this value right here. I'm allowed to do that because 36 minus 36 is 0. So that's I'm not changing the equation. There we go. So I factored the 1 from the x squared and the 12x, and then I added and subtracted 36. Next, we keep these three terms in the brackets. So I do y equals 1. I keep those three terms, x squared plus 12x plus 36. And now we're going to have this negative 36 that I want to move out. I want to get rid of this from the brackets. But to do that legally, I have to multiply by the 1 that's on the outside. So I multiply 1 into the 36. 1 times negative 36 is negative 36. And this is what I get. Final step. The trinomial here, this bracket with the three terms, will always factor out perfectly. In fact, it's called a perfect square. The two factors are going to be the same. And the quickest way to get the factored form for it is to write x and then go to what we did right here. That's 6. That's going to show up here. So I say plus 6. And then negative 36 plus 41 is a plus 5. So that's how we complete the square. Let's do another example where I'm going to complete the square. Here's an example where I have a 6 in front of the x squared. Again, f of x or y, it doesn't really matter, but it represents the y variable. So y equals, I take out the 6 from the first two terms. Just the 6, that's the process. So I do it like this. Put them in brackets so I understand that I'm only factoring out of these two. Right, so brackets are good, or even underlining them at the start that you're going to factor from those two terms. I take out the 6, factor out the 6. And now I have to think about what should go in the brackets to complete the problem. 6 times what is going to give me back 6x to the 2? That would be x to the 2. And then 6 times what is going to give me 60x? Well, it's 6 times positive 10x. 6 times positive 10x would give me back the 60x. Next, we are going to add and subtract the magical number I talked about. Add and subtract a value in this bracket. This time, I'm going to take the plus 10, take that number, divide it by 2, and square it. It's a plus 10 again. Divide that by 2, square it, and that gives me 5 squared, which is 25. So I'm going to add and subtract 25. Just like the previous problem, we keep these 3 in the brackets. So we have x squared plus 10x plus 25, but we want to remove the negative 25 from the brackets. Remember though that in front of the bracket, there is a 6. So if you want to remove the negative 25 from the brackets, you will need to multiply it by the 6. So I'm going to take the 6 and multiply it by negative 25, and that's going to give us negative 150. Final step would be to factor this out and do the work for negative 150 plus 155. So y equals 6. And again, this is a perfect square. It's going to be one of those that factors out perfectly like this. Negative 150 plus 155 is positive 5. Okay, so in the brackets though, I'm going to have x, and just like the previous problem, I take this number right here. That's what I write over here. So it's x plus 5 squared plus 5. Now you might wonder if this is right. Some of you will wonder if these are truly the same. So I'm going to say, really? Are those actually equal? Well, let's find out just for fun. X plus 5 squared is x plus 5 times x plus 5. To multiply these together, I do x times x times 5, and then I repeat the process with 5x and 5 times 5. X times x is x to the 2. X times 5 is 5x. 5 times x is also 5x. 5 times 5 is 25. Collect like terms, we get x squared plus 10x plus 25. So yes, they are the same. You just have to trust the process.